Welcome students. Today we are going to learn part 2nd from lesson number 5, language of chemistry. And the next topic from this part 2nd is that molecular formula of a compound. Students, each compound is represented by a chemical formula with the help of the symbol and valences of different atoms present in it. So, the molecular formula represents the molecule of compound. And students, the smallest unit of compound is the molecule. The basic unit of the compound is the molecule. Students, if we want to define molecular formula, so a molecular formula of a compound is the symbolic representation of its molecule, and it shows the number of atoms of each element present in it. Definition of molecular formula is that a molecular formula of a compound is the symbolic representation of its molecule, and it shows the number of atoms of each element present in it, and these atoms always combine in whole number to form molecule. That's why students, the molecule is the smallest unit of compound. Students, for example, we will learn for that sulfur dioxide. Sulfur dioxide gas is made up of 1 atom of sulfur and 2 atoms of oxygen. The 1 molecule of sulfur dioxide is made with these 2 elements. And students, when we are writing the molecular formula of sulfur dioxide, we are able to write in that way, it is SO2. So students, here we completed about the molecular formula of compound. Now students, how to write the chemical formula of the compound? Always remember, writing the chemical formula of the compound, the 2 informations are very important. The first information is that the symbols of elements or the radicals which are the constituent of that compound, that we have to know. And the second information is that we have to know the valences of the elements and the radicals which are present in that compound. So that first we have to learn, and then we are going to make the chemical formula or molecular formula. And students, the method is used to make the molecular formula of the compound is called as a crisscross method. Now students, I am going to explain to you about the crisscross method. So if we want to make the molecular formula of the compound, how we will make? The first step of this, that first we have to write down the symbols of that element. Then second step we have to go for that, we have to write the valences of that element. In third step, we have to interchange the valences. The element right hand side and left hand side. So right hand side valency will go to the left hand side, and left hand side valency we have to transfer to the right hand side. That is called as a interchange of valencies. And after that we have to write down as it is that molecular formula. And after that we have to use the rule. Some rules are there. When 2 numbers are the same in the molecular formula, we have to reduce that, and as it is we have to write down. So students, I am going to explain some examples here about how to make the molecular formula. Students, the first example is the magnesium chloride. Write the symbols is the first step. So on left hand side we have to write down the symbol of magnesium, and on the right hand side we have to write down the symbol of chloride. Second step, write the valency of the symbols. So first we have to write down the valency of the symbol magnesium is the 2, and the chloride having the valency is the 1. Third step, we have to interchange the valency number. So magnesium will come to the 1 and chloride will to the 2. Then after that, write the interchange number at the base. So Mg1Cl2. But students, when we are going to the step number 5th, write the formula of the compound. So we have to ignore base number if it is 1. That's why we are ignoring the Mg, that 1 number. So our chemical formula of the magnesium chloride is MgCl2. So always remember students, the number 1 with magnesium is not written in the formula because the symbol itself represents one atom. One more example again I am going to explain here. The second example, calcium oxide. Step first we have to write down the symbol. Calcium symbol is Ca and oxide symbol is O. Valency of calcium second step is the 2 and the valency of oxide is the 2. So both valency after writing third step. We have to interchange the valency both. So calcium side will also 2 and oxide side also 2. So that step 4 we have to write down the formula as it is Ca2O2. And step 5 students, reduce the valency number to the lowest ratio if possible. That's why the molecular formula of calcium oxide is CaO. So students, in that way we have to write the chemical formula of the compound. Here I am explaining about the molecular formulae of some compounds. Name of the compounds and molecular formula. Carbon dioxide CO2, sulfur trioxide SO3, nitrogen dioxide NO2, phosphorus pentaoxide P2O5, sodium oxide Na2O, aluminium oxide Al2O3, silicon dioxide SiO2, ammonia NH3, iron second sulfide FeS, hydrogen sulfide H2S, sodium chloride NaCl. So students, some examples here I explain about the molecular formulae and common compounds. Students, next topic of the lesson is the significance of the chemical formula or molecular formula. Students, molecular formula not only save our time, space or energy, but this molecular formula give us the information. Now which information we are getting? That are the significance of the chemical formula. And the first information is that chemical formula represents one molecule of a compound. That's why the smallest unit of compound is the molecule. Second information is that the number of each kind of atoms present in it, that we are understanding with the help of chemical formula. Third information about the chemical formula is that the mass of one molecule of the compound can be calculated if the atomic mass of each atom present in the molecule is known. And students, the molecular mass is the algebraic sum of masses of all atoms present in given molecule. Then we are able to calculate the mass of the compound. So students, this information we are getting with the help of the molecular formula. Now this all I will explain with the help of the examples. Example first, a molecule of sulfur dioxide is represented by formula SO2. Here the elements present in it are sulfur and oxygen. One molecule of sulfur dioxide has one atom of sulfur and two atoms of oxygen. And students, molecular mass of sulfur dioxide is obtained by adding the masses of each atom of sulfur and oxygen. Atomic mass of sulfur is 32 AMU and oxygen is 16 AMU. Therefore, the molecular mass of sulfur dioxide is equal to 32 plus 2 multiplied by 16. The answer is 64 AMU. Students, now what is mean by atomic mass? The mass of an atom is called its atomic mass. And since an atom is very small, it is not possible to measure its mass in gram. Therefore, mass of a light atom like that hydrogen or 1/12 of the mass of carbon or 1/16 of the mass of oxygen is taken as a standard unit with which mass of an atom of any other element is compared. Students, Carbon is the most suitable and most widely accepted standard unit for the measurement of atomic mass. This is known as atomic mass unit, and in short we call it as a AMU. Atomic mass is also known as relative atomic mass. It is determined for an atom by comparing it with a standard unit. Students, here I am explaining about the atomic masses of some elements. Beryllium atomic mass is 9. Silicon atomic mass is 28. Boron atomic mass is 10.81. Carbon atomic mass is 12. Hydrogen atomic mass is 1. Helium atomic mass is 4. So students, in that way we have to learn about the atomic mass. Students, note first one point. Atomic mass can be a whole number or fraction, as it is the average mass taken for the different isotopes of an element compared to the standard unit. Usually we consider the values by rounding them off. So accordingly, sodium is 23, potassium is 39 and chlorine is 35.5. In that way we are explaining. So students, in part second we learn about the molecular formula of compound, how to make the molecular formula, the method we call Crisscross method. Then we learn the significance of the molecular formula of compound. The next point we learn about the table, some examples of compound and molecular formula. And the next topics we learn, students, about the atomic mass. So students, here we completed our part second. Thank you.